Hello students, in this video we are going to discuss 5.1 and 5.2 from work, energy and power. The sign of the work done by a force on a body is important to understand. State carefully if the following quantities are positive or negative. Work done by a man in lifting a bucket out of a well by means of a rope tied to the bucket. Work done by gravitational force in the above case. Work done by friction on a body sliding down an inclined plane. Work done by an applied force on a body moving on a rough horizontal plane with uniform velocity. And work done by the resistive force of air on a vibrating pendulum in bringing it to rest. We will discuss one by one. While coming to the first one, work done by a man lifting a bucket of water, bucket out of a well by means of rope tied to the bucket. Assume that this is a bucket and it is lifted up with certain force, and this body also is getting the displacement in upward direction. Therefore, work done here is equal to F bar dot S bar, Fs cos 0, that is simply plus Fs. So, the work done is positive. Coming to B. Work done by gravitational force in the above case, but actually the gravitational force will act downwards. So W is equal to F bar dot S bar. Here F is cos of 180 degrees. Here I am writing F suffix G, the force due to the force due to earth, that is gravitational force, it is nothing but minus Fg into S. So work done is negative. Because the displacement and force are both are opposite in direction. Previous case A, force and displacement both are same in direction. Coming to C, work done by friction on a body sliding down an inclined plane. We can take the situation like this. This is an inclined plane. The block is sliding down. Then automatically the frictional force will act upward direction along the incline. In this case, the displacement of the body will be downwards, frictional force will be acting upwards. Therefore, work done by the frictional force here negative. Coming to D. Work done by an applied force on a body moving on rough horizontal plane with uniform velocity. So the block is on a rough horizontal surface. The force is acting on the body and the body also getting the displacement in the same in direction. So then automatically the force and displacement both are in same in direction. The work done will be positive. Coming to E, work done by resistive force of air on vibrating pendulum in bringing it to rest. In this case, the work done is negative because the resistive force of air acts in a direction opposite to the direction of motion of the vibrating pendulum. Coming to 5.2. A body of mass 2 kg initially at rest moves under the action of an applied horizontal force of 7 Newton on a table with a coefficient of kinetic friction 0.1. Compute the work done by the applied force, work done by friction in 10 seconds, work done by the net force on the body in 10 seconds, change in kinetic energy of the body in 10 seconds, and interpret your results. Here the data given is M is equal to 2 kg initially at rest, so U is equal to 0, and applied force F is equal to 7 Newton, coefficient of friction mu suffix k is equal to 0.1, and t is equal to 10 seconds. To find the work done, even though we are having the force, but we should have the displacement. So to find the displacement, we want net force. Coming to the frictional force, F suffix k is equal to mu k suffix n. The body is on a horizontal surface. Applied force is F towards right, assume. Frictional force will be towards left, and normal reaction acting upwards, weight will be acting downwards. So mu k into n is equal to mu k times of n value is equal to mg, that is equal to 0.1 into 2. If you are taking g value is 9.8, its value will be 1.96 Newton. Therefore, net force on the block, if you are naming it, suppose say F dash is equal to F minus Fk, that is 7 minus 1.96 is equal to 5.04 Newton. Now the acceleration of the body, A is equal to, we have net force divided by m, that is equal to 5.04 divided by 2, that is equal to 2.52 meter per second square. Now we will calculate the displacement. S is equal to ut plus half at square, that is u is 0, so 0 plus half 2.52 into time interval is 10, so 10 square, that is equal to 126 meter. So the block travels 126 meter in the direction of applied force. Now we will calculate one by one. Work done by the applied force in 10 seconds. Here work done by applied force W suffix F I am writing, that is equal to F into S cos 0 degree. Y means F and S both are same in direction, that is simply Fs 7 into 126 882 joule. Coming to B, work done by friction in 10 seconds. Work done by friction is equal to, so frictional force into displacement, but it is negative. Y means the direction of the frictional force and displacement both are opposite in direction. So Fks cos of 180, it will be minus Fks. So 0.96 Newton into 126 is equal to minus 246.9 joule. And the third sub question is work done by the net force on the body in 10 seconds. See, work done by net force is equal to F dash is net force we have taken into S. Here net force will be towards right, that is in the same direction of displacement. That's why I am taking positive F dash S. 5.04 into 126 is equal to 635 joule. And coming to fourth sub question D, change in kinetic energy of the body in 10 seconds. So change in kinetic energy we need to find out means we need to find out first of all the final velocity. So the final velocity V is equal to U plus AT. So 0 plus U is 2.52 into 10, that is equal to 25.2 meter per second. Now change in kinetic energy is equal to final kinetic energy minus of initial kinetic energy. Half into mass is 2, the final velocity is 25.2 whole square, initial velocity is 0, so initial kinetic energy is 0, that is equal to 635. So check here C and D. From both of them we can say that The change in kinetic energy of the body is equal to the work done by the net force on the body. This is also known as work energy theorem. Thank you.